Hi, and welcome to engineering, not coding. In a cloud native world where every megabyte of RAM, every second of startup time is expensive for companies, and the traditional Java applications are becoming increasingly difficult to deploy. There is the need for a framework that is optimized for cloud native deployments. And in this video, we are going to take a look at this one particular framework called Quarkus that is gaining a lot of attention in the backend engineering development environment. So come with me while we take a look at what Quarkus is, what is the advantages it brings to cloud native systems, and also we are going to show a little demo to illustrate something that is unique about Quarkus. So let's get into it. So we are going to talk about this. I have some slides, little slides that I prepared to just make the discussion a little bit interactive. So the question is, why backend engineers are learning Quarkus? A lot of developers, sincerely speaking, spend so many years learning frameworks, but really still struggle to become real backend engineers. And it's important to admit this because one reason is that backend engineering itself has changed dramatically. It has evolved. Modern systems today are cloud native, as I said before. So companies now care more about startup speed, memory efficiency, infrastructure optimization. And so it is important that backend engineers have this shift of paradigm shift, so they can be able to meet up with the expectation of real world. And what is the actual problem? Traditional Java applications are extremely powerful and they are still widely used today. But many older systems, as we all know, were designed before these cloud native infrastructures became very dominant. So modern systems now uh, are heavily deployed on containers and use a lot of microservices. So, startup speed, memory becomes very, very important. So if you are deploying, for instance, in Kubernetes environment, applications constantly they scale and then restart dynamically. And so an inefficient and inefficient services quickly become expensive to scale, and this is very cost alarming for companies. So what is Quarkus? Well, Quarkus is a modern Java framework just designed specifically for cloud native applications. So it is not something that they are trying to improve. It was designed with the aim to with the focuses heavily on Kubernetes optimization, fast startup time, low memory consumption, and developer productivity. So Quarkus was originally, as I said, is not an upgrade. The purpose for it was designed from the beginning with cloud native engineering in mind. Why modern backend systems care? Why should they care? Now, modern backend systems rely heavily on microservices, containers, and also Kubernetes for orchestration. Now, smaller lightweight services are easier to deploy, scale, and recover efficiently. Then you also it becomes cloud. You get to understand that containers are also solve one major engineering problem teams have faced many years, meaning applications behaving differently across environments. So Kubernetes then automated infrastructure operations like scaling, deployment management, and failure recovery to 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 mitigate the performance issues that were identified in the early Java deployments. So Why Quarkus? Because there is already Spring Boot that is has a large ecosystem. So now naturally many developers will ask, if Spring Boot already dominates enterprise Java development, why then should I be interested in Quarkus? Well, Spring Boot remains one of the most major and widely used Java frameworks today, no doubt. But you see, Quarkus focuses much more aggressively on cloud native optimization, speed, startup speed, and lower memory consumption. And so this makes it especially attractive for Kubernetes, for containers, and for serverless environments. So, well, but this discussion is not really about one framework replacing another. Different engineering problems, we all know, require different tools to tackle them. So why should engineers use Quarkus? Why should engineers use it? Well, Quarkus, as I said, is especially useful is especially useful for microservices architectures, serverless systems, and cloud native backend applications that requires fast startup and efficient scaling. And lightweight services become easier to scale dynamically and more efficient to operate in distributed systems. And honestly, this is the point. This is where many developers begin realizing that modern back engineering is becoming deeply connected to cloud infrastructure itself. And this is really something that we need to understand. Now, what is a career perspective for backend engineers? Well, strong backend engineers should be able to adapt to emerging technologies. And learning frameworks like Quarkus helps developers better understand the direction modern backend engineering is moving toward. Well, backend engineering is not about memorizing frameworks. It is about building scalable, reliable, efficient systems that solve real-world problems. And this is important because it helps us to understand why it's important to always be abreast with new technologies that is evolving to solve real problems. So we are going to look at a demo, a simple Quarkus project that I'm going to run locally on my computer, create a simple REST endpoint, observe startup speed. We are going to observe the startup speed, and also to be able to understand why the developer experience. So let's get into it. I have my application running, so let's go into it now. So I'm going to just demonstrate to you how hot live reload works in Quarkus, and also how good the startup is. So I have here a simple project. It's a Java project, as you can see, with a Quarkus as the framework. So you can see I have a Quarkus live reload resource, just a simple endpoint that I've created, simple REST endpoint that I've created. So we'll go to, please take a look in the terminal, because you'll be able to see how the application works as we go to the web, to the browser to test it. So I'm going to go to the browser and then try to go to this endpoint, that is demo/hello. So exactly localhost at the port 8080 demo hello. So I go to the browser, I type my localhost, and then I go, and then immediately it gives me hello Quarkus REST API. Now, what are we going to demonstrate now? Our purpose is to demonstrate that whilst we modify this code in real time, we can also be able to see the uh, the modification taking place. So I can just type hello engineering. engineering viewers. Just something simple for us to take a cue. Okay, so I go again to the browser, and then I reload just this page. Boom, and then see hello engineering viewers. Now look into the terminal. You can see this live reload. So this is a hot reload. I didn't restart the the project. I didn't do anything. All I did is to modify and then immediately go to refresh to see the modification take place. And look at the time. Look at the time. Very, very good for developer experience. So you don't just you don't you, this helps you not to think about trying to start the application, rerun it because you have modified something. No, all you need just to be doing is writing, modifying, and just testing. So let's try to do something. Uh, let's try to create a new endpoint. Let's just copy and paste this one. Let's copy and paste this one. Okay, so I'm just going to change the method to time, just for us to log the time. Okay, also this, let's change this to time. So I'm going to, instead of me returning this string, I'm going to return a local date time actually. So I'm just going to return local date time to string. So again, I modified this. Actually, I created a new REST, REST API, but then I created a new REST API, as you can see. So I'm just going to go to the terminal, the browser again, and instead of hello, I put time, right? And then I reload again, exactly see what happened. So I didn't restart the application. All I did was to just go modified, I created even a new endpoint. And then see again, live reload, total time just 1 second. This is very good. This is in my machine. So imagine whilst we deploy this on a system that is very good. So from here you can actually see importance the importance of Quarkus, what it helps to do actually. It is a very good framework designed specifically for uh, backend engineering in cloud native systems. So we are going to just stop the demo now. Okay, so we have almost come to the conclusion of the video today, and I hopefully we have been able to learn something, especially how Quarkus helps developers so they can be able to just uh, write, modify, and then test without thinking about rerun the application, restarting, and all that. So in the next video, we will try to see. Actually, I'm trying to see if you can be able to build just a simple Quarkus project from scratch, so we can see how the elements connect to each other. We can use is basic. We will just do it from the Quarkus IO. So I can just we will just create maybe one or two REST API and test it in real time. So I invite you to subscribe, watch, and comment, and then like and share to your friends and colleagues who are also in need of engineering, not just coding. So this is a real example of what Quarkus offers in real systems. Thank you, and see you in the next video. Bye bye.